This crazy limit expression was at the end of the movie Mean Girls, and I had to pause the movie because it was going to bug me until I solved it. We're going to solve this together like ninjas, so smash that like and subscribe button. Let's get started. When you plug in x equals 0 to try and solve this, what do you come up with? Leave a comment below and tell me what you think. Okay, so if you did this correctly, you'll find that the natural log of 1 is 0, minus sine of 0, which also gives you 0, all over 1 minus cosine squared of 0, which is 1. And there's a bit of a problem here because we get this expression 0 over 0 here, which doesn't really leave us with any answer. But there's a cool trick because this is what's considered an indeterminate form, and we can apply L'Hopital's rule here. With L'Hopital's rule, you can go back to the original problem and solve it by instead taking the derivative of the numerator and denominator separately. So for this expression, natural log of 1 minus x minus sine of x all over 1 minus cosine squared of x. If you take the numerator's derivative and then do it separately for the denominator, what do you come up with? Okay, you should realize that for natural log of 1 minus x, we can use the chain rule. We get 1 over 1 minus x times the derivative of the inner function, which would be negative 1, minus cosine of x all over 0, because the derivative of 1 is a constant, and that gets you 0, minus 2 cosine of x, negative sine of x, because for cosine squared of x, we can also use the chain rule here. So when you simplify this further, you're going to find that you get negative 1 over 1 minus x minus cosine of x over 2 sine cosine of x. Now, when you plug in 0 here, we're going to have a little bit of a problem again. And let me know what answer you come up with, because something is going to stand out here. Okay, when you evaluate this for x equals 0, notice that when you simplify this further, you're going to come up with negative 1 minus 1 all over 0. And now we have a bit of a problem still because we got an answer that's negative 2 over 0. How on earth does that tell us that the limit even exists? So you might be wondering, okay, did you just waste your time with L'Hopital's rule? Well, the answer is no, because the beauty of it is that we can still work with this new limit problem that we got from L'Hopital's rule, because it is simpler than the original problem we started with. So the next thing I'd recommend you do here is we need to look at how we approach x equals 0 from either side if we were to look at a graph. So the idea here is we're going to start out by first evaluating the expression by approaching 0 from the right. We're going to repeat it by approaching from the left. And we want to now look at, okay, if we got the same answer for both, what does that tell us? So stick around because I'm going to show you exactly what we're looking for here. Now, when you start out by solving this limit for x as you approach 0 from the right, the idea is that think about not plugging in 0 from the get-go for x, but values that are slightly positive. In other words, values that are just over 0, like 0.001 or 0.11, very small values of x. And for each part of this expression, if you look at it, you'll notice that, okay, well, for negative 1 over 1 minus x, no matter what you plug in for small values of x, that's going to remain less than 0. Cosine of x will be greater than 0. And for sine of x, cosine of x, that will also be greater than 0. And you can try this for yourself to verify. So now when we go ahead and evaluate the expression at x equals 0, the main thing you want to look at is, okay, when you get this expression down here, negative 1 minus 1 over 0 like we did before, keep in mind here, I'm marking the denominator as 0 plus, because remember, we're approaching it with very small positive values of x. The key idea here is that the numerator is negative, right? Because you get negative 2. But because the denominator is slightly positive, very small values that are greater than 0, you're dividing a negative by a denominator here that's positive, but getting very, very small. So this expression actually is approaching negative infinity as you take the limit as x gets infinitesimally small. Now, this is homework for you. So if you were to go back and repeat this now by approaching x from the left-hand side of 0, meaning you're choosing values of x that are super small but super negative, like for instance, negative 0.003, etc., leave a comment and tell me what answer do you come up with. Okay, I'm going to skip ahead a bit. I'll scroll a little bit in case you need to go back here and review. But if you repeat this, you're going to find that just like before, we're going to get an answer that is negative 2 over 0, except for the denominator here, the expression 2 sine of x cosine of x for very small negative values of x actually gives you a denominator that's negative. So because we're dividing a negative by a negative here, this approaches positive infinity. And that's super important because guess what? If we go back and review our answers, depending on how we approached zero, if we approached it from the right, we tend to negative infinity. And if we approach it from the left, we tend to positive infinity. Now, think about limits and continuity. What is your answer here? Okay, you should realize that because you get a different answer from however you approach x equals 0 from either side, the answer here is that the limit doesn't exist.